In this tutorial video, we're looking at the normal distribution involving probability. We're going to look at 7 examples. The first 6 are going to be read from the drawings, from the bell curve basically. And the 7th one, we're going to look at a word scenario which involves mobile phone tariffs. So we're going to work our way through the 7 of them. Feel free to skip to a particular one you want. But if you watch the 7 of them, hopefully you'll build some good knowledge on how to find probabilities based on the normal distribution, or the symmetrical curve, or bell curve in other words. You'll need your log tables handy, page 36 and 37, in order to translate your z-score to a probability. So let's have a look at the first one here, this top left-hand corner one, the probability of z being less than or equal to 0. Okay, so this one shouldn't be too bad. Probability of z being less than or equal to 0.0. So first thing I'd always do there is draw your symmetrical curve, your bell curve. So I've done that out already. Next thing you should always do is mark in your center point, which is always 0.0. So that is always going to be 0. It's a symmetrical curve. So to the left of that graph, or that line, is half of the graph, and to the right of that blue line is the other half of the graph. So that one you can basically easily spot. Well, what's the probability of my z-score being less than 0? So it's basically all of any of that region here to the left of 0. Well, we can read that basically from our symmetrical graph. Any portion in that region is going to be half, or 0.5, or 50%. So that one we're reading basically from the bell curve. If we wanted to use our log tables for that, we go to page 36. And you go to your z-score of 0.0, which is here, and that's bringing me to 0.5 or 50%. Now, just a note to remember, going forward, you always read your symmetrical curve, your bell curve, from right to left. So that's how you measure it. You start and you basically get the percentage to the left of that line. Now, just keep that in mind because we're going to need to flip that in a question or two ahead. Okay, so let's have a look now at our second question. The second one here is asking us to find the probability of z being less than or equal to 1.83. Again, you draw your symmetrical curve, you mark in your 0, 0, and I then mark in my 1.83. Now, how your symmetrical curve or bell curve works, if you remember your knowledge of the empirical rule, it basically looks like this. It starts at 0, then it goes up 1 deviation, 2 deviations, 3 deviations. And we go back 1 deviation, back 2 deviations, back 3 deviations. Now that region there, basically between those two figures, accounts for 99.7% of the graph. So when you're filling in your probability, like in this question 1.83, just kind of mark it in where an approximate location. It doesn't have to be an exact science, but 1.83 is going roughly around that green dot. So when I come back up to my graph here, I'm just going to draw in the line, and that's going to be my 1.83. So just make sure that the positive goes to the right of the 0, negative goes to the left of the 0. And this particular question, like I said, wants the probability of z less than or equal to 1.83. So we're going backwards again. So we're looking for this region in here. So we're looking for the probability of selecting a piece of data from in that region. Now, I can't do that from looking at the picture. I need to use my z-scores from page 36 and 37 in my log tables. So let's do that. We're looking for 1.83. Now, when I go to page 36, you can see that it brings me to 1.0. I want 1.83, so I just need to flick over onto page 37. And now I'm looking for 1.83. So I go down underneath my z and I find 1.8, which is here. And I come across to 0.03, which is here. So 1.83 is 0.9664. So that's my answer, 96.64% in other words. So if I write in my solution, the probability of z being less than or equal to 1.83 is equal to 0.9664, which is the same as 96.64% if I multiply it by 100. So 96.64% of the data lies to the left of 1.83. That's basically what that question is getting you to do. Okay, part 3 is asking me to find the probability of z being greater than or equal to 0.7. So first thing we need to do is mark in 0.7. Always draw your bell curve like we said. Mark in your center 0. Then I'm looking for 0.7, which is probably very close to the 0, which is around there. So that's 0.7. Now, unlike the other two questions we did, we're looking for greater than or equal to. So I'm looking to the right-hand side of that line, which is this region in here. So we're looking for the probability of a selection taken from that region here. Now, how we do these is slightly different to what we did. First thing I'm going to do is I'm going to find 0.7 from page 36 in my log tables. And you can hopefully see that 0.7 is getting me 0.78 or 0.7580, so 75.8%. That's the probability of being less than 0.7. So let's just bring that up and mark it on our diagram now. So that is telling me that 0.7 of a z-score is giving me 0.7580 as a probability. Now, like we said at the start, we always read these graphs from right to left. So that's telling me that everything to the left of that line is 0.7580. But I want everything to the right of that line. This is the region that I want. I want that proportion here. And in order to find that, like all probabilities, they must total 100% or 1.0. So therefore, my answer in this case is going to be my 100% or 1 minus the 75.8% or 0.7580. And when I take them away, I get 0.242. And that's telling me that that green region in here is approximately 24.2% or 0.242. So just watch out for the direction the inequality is pointing. If it's pointing to the right, greater than, you need to subtract it from 1. Okay, that's the third one done. Let's have a look at it, part 4. So from the picture, we're going to write down the probability. What's it wanting us to do? It's asking us to find the probability of z being less than or equal to minus 1.92. So that's what it's basically wanting us to find here. Now, that is the same as the probability of z being greater than or equal to positive 1.92. Because let's see how that would look on our picture. If I was to mark positive 1.92 on this diagram, because the graph is symmetrical, this region that I'm colouring in green is the same as what they've marked on the diagram. So that's what I'm going to work to. Because if you look at your log tables on page 36 and 37, it doesn't do negative z-scores. So it doesn't do negative 1.92. But we can find positive 1.92 from my log tables. And when I go to the log tables and find positive 1.92, I get, what am I getting? I'm getting 0.9, where are we? 1.92, 0.9726. So that's the probability of 1.92. Now, but that is, again, always reading from the line to the left. So that's what that's found me there. It's 97.26% falling along that red line. I don't want that red line. I want this region in here in green, this portion here. And in order to find that region, it's going to be, therefore, 1 minus 0.9726. So I'm looking for that other little region, which is going to give me a probability of 0.0274. Now, Therefore, that's the same as the probability of z being less than or equal to minus 1.92 is equal to 0.0274. Because our graph is symmetrical, those regions are the same area. And that's why our log tables only works with the positives, because the negatives are just going to be the same answer. Okay, let's have a look at another one here on a picture. So it's asking us to find the probability of selecting the green area. Now let's just put that into language, first of all, into mathematical form. So it's the probability of being between minus 1.8, z is between that and positive 1.8. So that's what they're asking us to find. Now, what we first of all can do is find the probability of 1.8 from my log table. So I'm going and finding 1.8, which is coming up as 0.9641. Okay, so that's a Z score of 1.8 translated to a probability of 0.9641. Now again, that is all of this region to the left. But there's a problem there. This region now that I'm marking in yellow has to be removed from that. So I need to chop out that little portion there. Now, we know now that that yellow region is the exact same as this yellow region. It's symmetrical, so they're the same area. And in order for us to find this yellow region, we can simply take away the 0.9641 from 100%, because we know that those two figures should add up to 100%, or 1 in other words. So therefore, I'm going to go 1 minus 0.9641, and when I take them away, I'm getting 0.0359. So it's roughly about 3.59%. Now, again, remember, if we go back to our red line, we have all of that region being 0.9641, and I want to cut out that little yellow portion, which is the same as this one here, which is now going to be a percentage of as a decimal, 0.0359, and when I take them away from each other, I'm getting 0.9282, and that's when I take out that little portion in here, because remember, the blue area here is going to be the exact same, which is 0.0359. So my answer there is 0.9282, or 92.8% is that green area in the picture. Okay, another one similar to that. Find the probability of z being between minus 0.31 and positive 0.73. Again, always draw your bell curve, mark in your center, 0. Then I'm going to mark in my positive 0.73. And then I'm going to mark in my negative 0.31. They want the probability of z falling between those regions. So again, I'm just going to shade it in. So they're getting me to basically find that area here. What's the probability of selecting something from that region in green? Now, first thing I'm going to do is I'm going to focus in on the 0.73 for a minute. So what I'm going to do here is I'm just going to draw some bell curves. So I'm just going to do a little bit of freehand sketching here. Oh, that's very poor, isn't it? Let's do better than that. Not great, but it's online. It's on the marker on the pen here, the stylus. So what are we looking at? So I'm just focusing now on the 0.73, which is this figure here. And I'll come to the negative 0.31 in a minute, but all I can do from the log tables is find 0.73 in the log tables, which will get me all of that region to the left of 0.73. Okay, so if I go to my log tables, find 0.73 in my log tables, that's my Z score, and that is giving me a probability of 0.7673. Okay, so that's what I found. That's the probability of being to the left of 0.73. Now I'm going to just draw another bell curve, same again. and I'm going to mark in my 0, and this time I'm focusing in on negative 0.31. And I'm going to find the probability of minus 0.31. So I'm looking for this region in here, basically. Now, as we try and find 0.31, remember that the log tables only does positives, so there's a little bit of extra work involved in this one. We can only find positive 0.31 in our log tables. And positive 0.31 is in fact going to give us all of this region. But that's not what I want. I only want this region here that, let's see if we can mark it in a different color. Let's color it in red pen here. So we're only looking for this portion of it here. But that portion that I'm coloring in red is the same as this because it's symmetrical. So what I'm going to do is I'm basically going to find 0.31 in my log tables, which is 0.6179. So that's giving me 6179. And in order to find the red area, I'm going to go 1 minus that. Because remember that I'm looking for that area just in red. When I take that away from 1, I'm getting, let's see, what am I getting? Sorry, I'm just spotting a mistake there. The probability of 0.31, I've written down 0.3. It's not 0.61, it's 0.6217. 6217. So again, just always be careful reading from the log tables. We can all make mistakes. So 0.31 is 0.6217. I take that away from 1 and I get 0.3783. Okay, now if I come back over, what that has found me now, if I just clear up my picture, is that region in green. But all I want, if we look at our main picture, is the region between them. So it's this proportion in here between these two. So that's all I want. So in order to find that region, what I need to do, so therefore my final answer is going to be 0.7673. Again, let's just mark it actually back onto the two sketches. If I was to imagine I was bringing that line down, so it's there, and I want this line coming up, which is there. So it's that region in the middle that I want. So I'm basically taking the full 0.7673 and subtracting the red region, which is 0.3783. And when I take them away, I get a final probability of 0.389. So the probability of selecting between minus 0.31 and positive 0.73 is 0.389. Okay, we've one example left. So a mobile phone company finds that its mobile bills are normally distributed with a mean of €53 and a standard deviation of 15. Find the probability that if a mobile phone bill is chosen at random, the amount due will be between €47 and €74. So this is kind of just like the one we were just looking at. It's one of these ones that you're between two figures. So let's just draw what they're asking us to find here. So again, I'm just drawing out my normal distribution. I'm marking in my mean, in this case, is going to be, is it €53? It is. And a standard deviation of 15. And they want me to find the probability that the phone bill falls between €47, which is to the left of 53, clearly. And it's probably not going down that far. That's because it's going up to €50. If I was counting in units, it would probably only bring me to about here. Which is 47, and up to what cost? 74 they want, which is probably about here. Okay, so they want me to find what's the probability that it's picked between that region. Now the only difference here is that in this question they've given us money. They haven't given us z-scores, so we basically need to turn these numerical values of euros into z-scores. Now the formula for a z-score is given as, let's just write it up here, z is equal to x bar, which is our sample mean, or our sample phone bill, minus the mean, which is mu, and divide that by the standard deviation. So that's the formula for our z-scores. And we basically just need to do that for €47 and €74. So we basically just have to do this twice. So let's go through it. So for 47 we have, so let's just put down our formula. Z is equal to x bar minus mu over our standard deviation. So that's giving me a z-score of x bar, which is my sample mean, which is 47, minus the mean, which is 53, over the deviation, which is 15, and that's giving me a z-score of negative 0.4. So I'm just going to mark that on my picture, and you can see actually that it is to the left of 53, which is a negative, and 0.4. So that's my z-score. I now need to find the z-score for €74, so I'm going to do the exact same thing again. So z is equal to x bar minus my mu over standard deviation. Z is equal to 74 minus 53 over my standard deviation of 15. Z is equal to positive 1.4. Again, you can see that that looks about right. It's to the right hand side of 53. It's into the positive region, so positive 1.4. Okay, so there are my two z-scores. So we've now moved away from currency to these numerical values of z-scores, which means I can now use them in my log tables to find the probability. So it's important that you put them into z-scores. So again, let's have a look at what that look like now on individual bell curves. So my first one here, if I was to sketch it, again, it's rough and ready, that would be 0, and I'm going back to negative 0.4. And if I look up positive 0.4, because that's all I have in my log tables, positive 0.4 is bringing me to 0.6554 in my log tables. So that's what that's finding me. If you go to 0.4 as a z-score in your log tables, it will find 0.6554. Now again, remember that we always read these from right to left. So that's giving me that region there. But that's not what I want. I want this region in blue. And I know, because this graph is symmetrical, that that region in blue is the same as this region in blue. So in order to find that region in blue, all I have to do is basically simply find that area there, because it's going to be the same as this one. And in order to do that, what I'm going to do is I'm going to take my full 100%, which is 1 minus 0.6554, and that's giving me a probability of 0.3446. So what that is finding is, let's just tidy up our picture, it's giving me that region now in, let's color it in green. So that region there is 0.3446. Next thing I'm going to do, I'm going to do the same thing again. I'm going to draw my bell curve. And I'm going to mark in the €74 or the 1.74 z-score. And I'm going to find 1.74 from my log tables and turn that into a probability. And again, just remember, you read it from right to left. And in my log tables, 1.74, why am I saying 1.7? It's 1.4, sorry, my fault. 1.4 is giving me 0.9192. So let's just write that in, 0.9192. Okay, now I don't need to take that away from 1 because that is what I wanted. I wanted everything to the left of 1.4, and that's what I found. So what does that now mean? In order to find this region back over on my main picture in the turquoise color, all I have to do now is I need to take away that green portion, which is here, away from the overall purple, which is all of this together. So I just need to take away my two solutions from each other and I will have my answer. So therefore, my final solution is going to be 0.9192 minus 0.3446. And that is going to give me 0.5746, or in other words, 57.46%. So if we just look back up to the question, find the probability that if a mobile phone bill is chosen at random, the amount due is between 47 and 74 euro. It will fall between 47 euro and 74 euro 57.46% of the time. That's basically what that is telling us. So that's our revision on our normal distribution of probabilities.